Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic static power. So static power is consumed by, that is, pseudo NMOS logic. So pseudo NMOS logic, here we are mainly used pseudo NMOS logic, nothing but, that is, PMOS transistor is permanently on. So the static power is consumed even when the chip is quotient state. Quotient means nothing but ideal state. So when the chip is ideal, the chip is exhibited, that power is called static power. So ratioed circuit it burn after, that is power in fight between the on transistors. So it leakage the cross between from the nominal off device. So even though it is switched off mode or on mode, the static power is consumed. So the mainly three parameters which are considered for static power: one is supply voltage VDD, another one is level converter, and third one is capacitance. And next to the static power, the chip contains the 32 word and 48 bit ROM. It uses the pseudo NMOS decoder for the bit line pull-ups. So one word line and 24 bit lines are high. So the beta is equal to 75 and VTP is equal to minus 0.4B. So based on this, we can find the pull-up current, pull-up power and static power based on this given formula. Next, the leakage power, that denotes the process has two threshold voltages and two thickness oxide. So one is subthreshold leakage for minus, that is 20 nanoamps, and 0.02 nanoamps. So 20 nanoamps for low voltage and 0.02 for high voltage. So gate leakage, that is 3 nanoamps for thin oxide and 0.002 for thick oxide. So it memories use low leakage transistors everywhere. Gates use the low leakage transistor on 80% of logic. So the leakage power, we can get the high leakage and low leakage based on the given formula. So you can get the static current first, and next static power from the multiplication of static current and power supply VDD. You can get 38, that is 38 milliwatts. Suppose if there is no leakage devices, the static power will be 749 milliwatts. So low power design principles, this is very important for low power VLSI design. First one is, you can consider the dynamic power reduction method. So alpha, that is clock gating when the device is sleep mode, and C, that is a small transistors, especially on clock transistors or short wires. Next VDD, that is lowest suitable voltage, and F, the lowest suitable frequency. So already we discussed alpha square C VDD F. So that is the dynamic power derivations. So this is the things we need to consider to reduce dynamic power. And next, for static power, we need to reduce, that is selectively you need to use the ratioed circuits. So ratioed circuits means we are using the pull up network for PMOS transistor and pull down transistor for pull down network, and selectively you need to use low threshold voltage devices. So threshold voltage is nothing but based on the particular threshold point, the device will be working condition. The particular point is called threshold voltage, that is biasing mode. What do you mean by biasing? That is the external given voltage. For example, the Zener diode biasing voltage is 0.6 voltage, means you need to give the external voltage or current to bring out the device into 0.6 voltage. Once if it is reached 0.6 voltage, you just stopped the given voltage or given current. That is called biasing. So two different voltage, that is threshold voltage used for static power reduction. One is low, another one is high. So if it is needed low voltage, so you can use the low threshold voltage device. If it is needed high, means that is you can use for high threshold voltage power. And next, the leakage reduction. So leakage reduction played a vital role to find the stacked device. Next, body bias condition. Body bias condition means the biasing conditions, that is substrate is connected with the upper or lower, that is connected with the power supply. VDD means it is connected to the power, and it is connected to the ground means it is grounded. And next, it is useful for the low temperature. So this is the method to reduce the static power reduction method. So this is very very important low power design principles. Next, the assessment. You need to reduce the dynamic power. Alpha, C, VDD, F, everything is reduced. Selectively use ratioed circuits. Selectively use low threshold voltage. And also for the dynamic reduction, that is these devices for body bias and low temperature. So this is the assessment method for static power reduction methods and low power design principles. Thank you.